Hello everyone, I'm Francine Kisha de Mesa, a 4th year BSCP student of Bicol University, Palangig. For this video, I'll be presenting my first laboratory activity in digital signal processing, which is the plotting analog signals. The goal of this lab is to generate and visualize analog signals like sine and cosine waves using Python. In this experiment, it aims to understand how to generate and visualize analog signals and to apply NumPy to create time domain samples and to use Matplotlib to plot sine, cosine, and combined waveforms. For the materials, I only use my phone with the PyDroid app and the Python libraries like the NumPy and the Matplotlib. Let's now move on to the code. Here's the code. I just copied it from my because I'm using my phone right now. And here's the code. First I imported the libraries, which is the NumPy for creating arrays and mathematical operations, and the Matplotlib for plotting graphs. The next is I defined a time vector t from 0 to 1 with a step size of 0.0. Oh, sorry, that's a mistake. It should be 0.01 only as written here. This defines the time duration for the signal. Then I created the sine and the cosine waves, which both have 10 hertz frequency. Then after that, I plotted each signal, the sine wave, the cosine wave, and the combined signal using the subplots for clear comparison. Here for the sine wave, here's for the cosine wave, and here's for the combined signal. Each plot includes labels, legends, and title, which makes it easy to analyze. Let's go back here and answer the guide questions. First one, what happens to the sine wave if the frequency is doubled? When the frequency of a sine wave is doubled, the number of cycles within the same time frame also doubles, which means the wave oscillates more rapidly, showing twice as many peaks and troughs compared to the original frequency. The graph here looks more compressed horizontally because more cycles fit in the same duration. Then the second question is, how does the phase difference between sine and cosine waves affect their combined signals? The phase difference between the sine and cosine waves affects how their combined signal works. When the two waves are aligned or in sync, they produce a similar wave pattern with the same number of cycles in each time interval. As you can see here, they almost, the three of them almost look the same because they're in sync and they're aligned. For the third question, what changes in the plot of the sampling interval 0.001 is increased or decreased? When the in my code, I used a sampling interval of 0.01. If I increase the interval to 0.01, fewer sample points are plotted, making the paragraph look rough or jagged. But if I decrease it to 0.001, the wave becomes smoother and more accurate since more points are used to represent the signal. As you can see here, sorry, the photo is kinda blurred because when I converted it to PDF. Here's the 0.001 and here's the 0.0001. For the last question, how do amplitude and frequency affect the shape of the plotted signals? The amplitude determines how tall or short the wave appears. Since it sets the maximum and minimum values of the signal, the frequency changes how many cycles fit in a given time range. Higher frequency results in more oscillations, while lower frequency shows fewer cycles. In simple terms, the amplitude determines how tall or short the wave is, while the amplitude The higher the amplitude, the smaller the peaks, the taller the peaks rather, while frequency controls how many cycles appear in the plot. While the higher the frequency, it gives more cycles and for faster oscillations, while lower frequency gives fewer and wider cycles. So that will be all for the laboratory 1. Thank you.